Is one component system. For one component system, water is taken as an example. Water, it can exist in all three phases, that is in the form of solid, in the form of liquid, and in the form of gas. Water can exist in all the three phases, and the equilibrium at a particular condition, it exists in three states. All the three states coexist, and therefore the equilibrium is written like this: equilibrium between solid, liquid, and water vapor. To understand this equilibrium, we take a phase diagram, that is, we study a phase diagram which is graphical data drawn between two factors. One is temperature in x-axis and pressure in the y-axis. The phase diagram gives the following information. It consists of certain curves, a triple point, and few areas. So in specific, the curves seen in the phase diagram are curve OA, curve OC, and curve OB. And the areas which are seen in the phase diagram are, this is considered to be one area, that is COA. This is one area where water exists in the liquid form. This is one area, that is area below BOA, where water exists in the form of water vapor. And this is one area, that is COB, where water exists in the form of ice. And we see a particular point called as triple point. These are the information which is seen in phase diagram: few curves, certain areas, and a triple point. So let us see what the curves, zones, and triple point represents. Curve OA, it represents the vaporization curve, that is conversion in or equilibrium between water in the form of liquid to vapor. So that particular curve is called as vaporization curve. And when we calculate the degrees of freedom for this equilibrium, that is F is equal to C minus P plus 2. In this particular equilibrium, when we count and see the components, both as liquid form or vapor form, water exists as a single component. Therefore, the number of component is C, and phases are 2. Here it is liquid phase, here it is vapor phase. So, therefore, phases are 2, components are 1. Applying this in the formula, F is equal to C minus P plus 2. Components become, the value of component is 1, the value of component is 2, and plus 2. So finally the answer F is equal to 1 degrees of freedom, which means to study such an equilibrium, on the curve, it is necessary to fix one factor, and other factor can be varied. For example, among the two factors, that is temperature and pressure, to study that equilibrium on the area OA, either temperature has to be fixed or pressure has to be fixed. So it is necessary to fix one factor and vary another factor. So that is the meaning of degrees of freedom. And therefore on the curve, the system is said to be univariant. One factor can be varied, the other is fixed. And the curve OB, that is, this is the curve OB, and that is the sublimation curve which shows the equilibrium between the solid, ice, and water vapor. The equilibrium is between ice and vapor. The name of the curve is sublimation curve of ice. Since the equilibrium exists between solid and vapor, to understand the equilibrium or to study the equilibrium, to study the system, the number of factors required are calculated using the formula F is equal to C minus P plus 2. Again, in the above equilibrium, ice is a phase, vapor is a phase, therefore two phases exist, but the component is single, that is water. So the values of C and value of P is applied as 1 minus 2 plus 2, and the value is 1. Again, to study the system equilibrium on this curve, it is necessary to specify one factor and vary the other factor. One factor can be varied, the other factor has to be fixed. So the system on the curve OB is said to be univariant. Now the curve OC, which is shown here, and it represents the equilibrium between the solid ice and liquid water. For such a equilibrium, that is solid and water, the phases are two. Ice exists as solid, water exists as gas. Two phases exist. The component is one. Therefore, to calculate the number of degrees of freedom, again the same value is applied. For component, the value is 1, and for phases it is 2, and therefore number of degrees of freedom becomes 1. So like the curves OA and OB, curve OC also, to study the system on the curve OC, one factor can be varied, the other has to be fixed. That is, the system becomes univariant on the curve. And next, the data which is given in the phase diagram are areas. Areas, that is AOB, AOC and BOC. It is AOB, this is one area, AOC another area, and BOC the third area. So below BOA, water exists in the form of gas. In the zone AOC, water exists in the form of liquid. In the zone COB or BOC, water exists in the form of ice. To study this system in this particular zone, the number of factors that has to be fixed and that can be varied is understood from the formula phase rule, that is F is equal to C minus 2 plus C minus P plus 2. And for the areas, if we want to calculate the formula, that is F value, C becomes 1 because in all the zones, either water it exists in the form of solid, or it exists in the form of liquid, or it exists in the form of gas. So therefore, it exists only in any one phase. So the value for P is 1, and always component is 1 component for water. So the value of C is 1, and when it is all applied in the formula, the value of F becomes 2, which means to understand or to study the system in the areas, the factors that has to be fixed is uh, temperature and pressure. Both can be varied. Either temperature also can be varied, pressure also can be varied, and a particular point in a particular point the system can be analyzed or studied, which means it is bivariant. There are freedom for varying both the factors. And the final thing which is seen in the phase diagram is a point called a triple point O, which means all the three curves meet at this point O. So the point O represents the equilibrium between all the three states, that is this equilibrium: water, solid, water, ice and water vapor. So all the three coexist at that point called O, which is triple point. And since all the three are coexisting, when we calculate the degrees of freedom, the C value takes 1 because it is one component system. P value, phases, since three phases are available, P value takes the value 3 and plus 2. So therefore the value becomes 0. The value becomes 0, which means the degrees of freedom is non-variant. So here two factors are given in the graphical data, but there is no freedom to vary temperature or pressure. Both has to be specified or both has to be fixed. Only at a particular pressure and a particular temperature this point O exists. Otherwise the equilibrium do not exist. That is the meaning. So therefore at a triple point the equilibrium or the system is non-variant. This point exists only at the pressure, that is 0.006, and at the temperature 0.01 degree Celsius.